Let's do checkpoint 6.17. They want us to consider the vector field f, which is x comma y, and the curve c, which is t comma t squared from 0 to 2. And then they want us to find the line integral of that function f over the curve and compare that with doing the same line integral except going the opposite way. Well, let's first establish some information about this line integral. That line integral, that's the integral over c of f dotted with t ds. There's a lot of ways to write this. We can write it as f dotted ds, where s is a vector. And I guess the way we can do this as a working definition is to have this go from as the integral from 0 to b, or a to b, of the function evaluated r of t once you have it parameterized, once you have the curve parameterized, r prime of t. And just remember, compared to the other line integral over a scalar function, we're not multiplying by the magnitude of the derivative, we're dotting by the derivative itself. Okay, so the big difference between going along the curve C and going the opposite of C is really just switching the sign and going from the limits 0 to 2 versus going from the limits 2 to 0, which we know by properties of the integral is just going to be negative. All right, well, let's do the computation for this vector field. We have the parameterization from R already, so we need f evaluated at r of t, which is going to be a vector. We put t in for x and t squared in for y, so that's that. And we need the derivative, and that's going to be 1 comma 2t, and we're going to take the dot product and integrate from 0 to 2. So our first integral going along the curve is going to be the integral from a to b, or in this case from 0 to 2, and we're going to take the dot product of t comma t squared, dot that with 1 comma 2t dt, and so the dot product is going to give us a t plus 2t cubed, so integral from 0 to 2 of t plus 2t cubed dt, and this is just 1/2 t squared plus 1/2 t to the fourth, evaluated from 0 to 2, and we put 2 in. We put 0 in, it's going to go away, so we can knock that out and put 2 in. We're going to get 1/2 2 squared plus 1/2 2 to the fourth. So 2 squared is 4. 4 divided by 2 is 2. 2 to the fourth is 16. Divided by 2 is 8. And so this is going to be 10. Now, like I had already mentioned, if we're going to go the opposite direction of C, then this is simply going to be the negative of all that stuff. It actually will be the integral from 2 to 0, because we're have a different starting point of all this stuff. Suppose we should put the dot product. And this is simply going to be the negative of that integral that we had before. Okay, so which is greater? It looks like the positive 10 will be greater. but they're really just the difference between them is just that they're opposites, off by a negative sign. All right, I hope that helps.